Okay, so in the last lesson we looked at the structure of the water molecule and how the water molecule forms hydrogen bonds and how those hydrogen bonds affect all of the properties of water. Um, when we talked about water, we were talking about just water molecules themselves, which would be, if you just had pure water molecules, that would be fresh water. But animals that live in the ocean live in seawater. And seawater is water that has gases and salts and other nutrients that are dissolved in the water as well, not just pure water. So in order to understand the saltiness of seawater, you need to understand what a salt is. And salts are simply molecules that are made up of two ions, okay, that are joined together with an ionic bond. So an ion, if you remember from chemistry, is an atom that has an electrical charge. So a salt is made up of two atoms that have opposite electrical charges that attract to each other. So like sodium chloride, which is your normal table salt, has a positive sodium ion and a negative chlorine ion, and the two are attracted to each other because of their opposite charges. So they are made out of ions. Salts in the ocean come from several different places, but one of the main places that they're going to come from is from rocks that are on the seafloor. So rocks that are on the seafloor, any sort of salts that are in them will dissolve into the water and then enter the water and become part of the salts in the water. And then also any sort of rocks that are on land, as the fresh water runs over them, they dissolve the salts and carry those salts down into the ocean and leave the salts in the ocean, deposit the salts in the ocean. Also, any sort of volcanic gases from eruptions underwater from the mid-ocean ridge would also help to put some salts and stuff into the water. And then any sort of salts that will dissolve from the atmosphere into the water as well would enter into the ocean that way. Here is a table from your book of the most common ions that you'll see in the ocean. And you can see up front or at the top, sodium and chloride are the two main things that you'll find in the ocean. So table salts is the main type of salt that you'd find in the ocean. You also have other things like sulfates and magnesium, calcium, potassium, and bicarbonate. But by far, sodium and chloride are the most abundant type of salt in the ocean. So another property of water that we are going to look at is water is actually a very, very good solvent. So it's really good at dissolving things because it is polar. So we talked all about like surface tension and stuff last lesson. Water, another property of water is that it's a very good solvent. And the way that it actually dissolves things is, like a salt, is because it has polarity. So it has a charge. So if you look at this picture down here at the bottom, you have your sodium and your chloride ions fused together to form your salt. So here's your chloride ion, and then here in green, this is your sodium ion. And they're attracted to each other because they are charged particles. So water, okay, here's our little water molecule down here. Okay, water has a negative side on the oxygen, and then it's got a positive side for the hydrogens. So this negative side of the oxygen is going to be attracted to the positive side of the salt molecule, which would be the sodium ion. And so that negative charge will be attracted to the positive charge. Other water molecules, okay, will be attracted to the chlorine. So the positive side of the water molecule would be attracted to the chlorine. And what you have is a bunch of these water molecules that are kind of gathering around the sodium chloride, and the negative side of the water molecule is arranging itself around the sodium, and the positive hydrogen side is arranging itself around the chlorine. And as these water molecules start to build up around the sodium and chloride, they're actually kind of like tugging on this ionic bond between the sodium and chloride. And as they keep tugging, more and more water molecules come, they pull the two ions apart, the sodium and the chloride. And once that happens, and they've pulled the two ions apart, then you can see right here at this part of the picture, you can see the sodium ion here in the middle, and then you've got your water molecules all arranged around it, and then you can see your chloride ion over here, and you can see all of the positives arranged around it. So the water kind of creates a buffer so that now these two salts can't get back together, the two ions can't get back together, and the salt has been dissolved into the water. So water is very, very good at dissolving things that have some sort of charge to them because it is polar. So